Hello, everybody. I want you to imagine for a minute that there is no such thing as a microprocessor. Have you guys ever gone to one of those places where they have a, it's called line shafting automation, where they have a motor in the corner of the building, and then there's a big belt that goes up, and across the top of the ceiling there's a line shaft that they have a motor in one corner that goes up to a belt, and then across this line shaft they have a whole bunch of pulleys of varying sizes and other belts that drop down, and there's machine one, and then there's down here there's machine two, and it's all mechanisms. And so you have one big motor, and this is the way automation used to get done. And so we don't do this type had really no automation to it, but it did allow you to have one motor, and then through mechanisms run a drill press, a cutoff, run different kinds of machines through cams and pivots and mechanisms. That's, in fact, one of the previous instructors of this class had a book, and the book was like 600 pages, and the title of the book was Mechanisms. And there are so many, there's the 4-link and the 3-link and I don't know, it was just amazing how many mechanisms people had thought up over the years. And so we use a few of these, but more and more the mechanisms get replaced by motors as we go along. So, but with PLC programming, this is, at some point you need to add automation into that. So what are you going to do? You're back before microcontrollers, but it doesn't mean that there aren't specific things. So if you start looking at a some sort of a controls, what are the controls that you need to put into a system if you're going to automate it? So if you're going to automate anything and you're the brain, think about your brain. What do you need to do? You need inputs, and then you need outputs, right? So what kind of inputs would you want on something like that you're going to automate? What are some of the inputs that you have on your machines?
Like a distance, maybe?
Okay. So what do you do? Like a distance, you mean you're measuring the distance?
Well, like how far your actuator would go out or something?
Right. Okay. So yeah, so you want to, you'd want something to measure or sense, right? And of those things, you can sense distance, right? You might want to sense how far something. How would you do that? How would you, back in this system, back here, how would you, if there's some mechanism that's moving from point A to point B, how would you actually measure if it got there? What would you likely have done way back when?
Good timer.
Okay, well, maybe, yeah. So let me put that down before I lose it. A timer. Okay. How would you have timed something back before a microprocessor?
Stopwatch, maybe?
No, stopwatch. Well, yeah, mechanical, right? Stopwatch is all mechanical. So a stopwatch, you could have done it, right? But that would have been a human doing it. How about if you wanted to automate the timing?
Neon oscillator or vacuum tube.
Yeah, you had these vacuum tubes, yeah, oscillators, and before that, Well, you had, yeah, it'd be a mechanical timer of some sort, right? And it physically would have you ever, well, all right, you guys have mechanical timers. Probably somewhere in your house is a mechanical timer that's plugged into an outlet. And what's it doing?
I know at my house it's controlling the sprinklers.
Aha, you have one that's controlling the spring. Now that one might be microprocessor, right?
No, it's
No.
it's an old school, just a ticker.
It's a ticker. Yeah, it is. It's a ticker. And so actually, the one I'm thinking of is we've got a light plugged into it, and it turns on the light at 7 p.m. and it turns it off at 11 p.m. Right? And it's a little timer that you plug into the wall. Any microprocessor in there? No.
Nope,
It goes tick
probably
tick
not.
tick 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 tick, right? And then at some point it clicks a switch. Okay. We can do timers without programming. Agreed? What else do you need to automate something like this? Well, we just did one thing. We had a switch, right? You had a timer and a switch to turn it on and off. So you had a timer. The switch, you could have used the switch for the distance. Could you have, if this were swinging, let's say that this mass was moving from point A to point B on a cam of some sort, could you put a switch over here that it hit the switch, and whenever it hit the switch, it made a circuit? Sure, right? So you could have automated and found out that this is moving back and forth and got some sort of switch input into your controller. What else do you need? What else did you want to do if you're doing automation? So we got switches, we got timers. What else would you want to do? What else are you guys going to do in your machine? Think about your napkins. What other things are you going to want to control?
How far the motor turns?
How far the motor turns. Okay, is that, how would we do how far the motor turns? Okay, so how far do you want the motor turn? You could turn it till it hits a switch, right? You could set up a little switch and it turns till it hits a switch. You could turn the motor on and then leave it on for a certain amount of time as it goes by. Are you wanting to go more than one revolution?
Yes.
How many
Yeah.
revolutions are you going to go?
I believe it was about 1.5.
1.5. Okay. So could you have, let's see, let's say, just amuse us all. Let's say that you said 5 revolutions, that the motor needed to go 5 revolutions, and that's what your mechanism supported. Okay. What would you want to do? What would you want in there? What mechanism would you put in there to figure out if it went 5 revolutions? You'd want something that, what?
Counts the revolutions.
There you go. You want a counter, right? Okay. So, and how would you do a counter without a microprocessor? Where have we done those? If you think about an answer, then flip your audio off and where have we done counters without a microprocessor? Where do you still do them?
Old clocks?
Okay, an old car. What were you counting in an old car? Yeah.
Oh, I said old clocks, but
Oh,
with like gears, like the ones that would just have a pendulum.
yeah. How is that? Hold on a sec. I still can't get away from this phone. Okay. I'm not sure how. I guess that's a kind of a counter because it gives you a different indication. But let's go with something where it gives you a number.
Rulers.
Mileage.
Odometer. There you go, an odometer. Odometer's a counter, right? And so it clicks off a certain click every time something turns. It clicks over one time, and then it counts something. It gives you a count, right? The only thing that that odometer doesn't do is it doesn't count up to something and then have an action. Is there anything you can think of that counts up to something that has an action? I can't think of anything either. Nothing comes to mind right now. Counter that counts up to something and then closes a switch or something.
What about like a timer? But like it counts down and then buzzes.
Yeah, so that's a timer. So in a timer, you're right. I'm trying to think of the actual, the timer is timing, actual time. I'm trying to think that a counter is counting number of events instead, and they're asynchronous events. The events could happen anytime. What else? Where could we count something like that and then have an action?
Well, there's those like person counters that they use at like stadiums that go back to 0 after you max them out. That's one thing, but that's just because there's no more numbers to.
Yeah. I mean, I imagine if we thought about it hard enough or Googled it or something, we could find some sort of thing that like counted cars and it let 5 cars go through, and then boom, after the 5th one, there was some mechanism that triggered it, right? And up went the wall, and now 5 more no more cars can go through, right? Click, 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 boom, something like that. So anyway, my point is, this controls of mechanisms has been done a long time before microprocessors.